Welcome to General Structures 2 and Lateral Forces, lesson number 4, example number 2. And it asks, which is more ductile? Or you could say ductile, a building frame system with concrete shear walls, or a moment resisting frame system with concrete special moment resisting frames? And the short answer to this is that the moment resisting frame is much more ductile than the concrete shear wall. And I'll go do a quick 2 second, or it's going to be longer than 2 seconds, but explanation as to why. And hopefully, I think they actually do have this explained a lot more in depth in the study guide I'm looking at, which is an older study guide, but one at least that you could take a look at, and it gives good information on this. So I'm going to do the different types of moment resisting frames and whatnot in different colors. So you're going to have this, well, first of all, a moment resisting frame, it'll be looking like this, where this is it's always difficult to explain this in simple terms, but you have for instance, if you cut this out right here, we'll put it over here, it can transfer a moment from this member to this member. So therefore, it's not like a pin. It's not a pin there. So you're not going to see. Let's say it's concrete. In concrete, you're going to have. It may even look like that in concrete, but maybe not. In concrete, you're going to have a certain amount of rebar to distribute that load. And it might be something like this. And obviously, this is not perfect. I'm just trying to, trying to show you how this would work. And this rebar would have to extend down a certain distance to make sure it's resisting that moment. And then you can also have a steel, which is steel. And these aren't exact diagrams of what these should look like, so do not think, oh yeah, that was close enough. They actually, if you want to, you can probably look it up on Google. Go up and look up moment resisting frames, look at some pictures, and you'll see a ton of different pictures come out about what these moment frames look like, but they'll have certain standards. So actually, let's say we're looking at this one right here. So that's continuous. Get rid of that. And this will come in. And I've explained this in past videos, but so you would have, let's say, a pin connection. You would have, this is an angle, and you have some bolts in there, and then you have some bolts coming in through here like so. So therefore, this is treated as a pin, where this is a 1 point, and it can theoretically, it will have a little bit of movement that way, which it won't be much. To make it a moment resisting frame, you have to do some other things. You could do welds, or you also have to pretty much you have to restrain that top flange and bottom flange. In short, that's all I'm going to say, and we're going to move on, because I'm sure you can take a look. Pictures will give 1,000 words here. Go look it up on the internet, and you'll be fine. But that's the type of situation where you have a moment resisting frame. In the end, going back to where we were at the beginning for explaining, is this, if it's a moment resisting type of frame, it will, let's say this bends like this. Well, that will bend like this. This, in theory, you can think of it, it's a good way to think of it, is this is going to keep 90. This will stay 90. So if it's bending down this way, to keep 90 degrees, it's got to come out right there. So it will come out like that. And over here, if it's doing the same thing, if it's bending, it looks like it's going up a little bit maybe, so it's keeping, and maybe it'll come in if you have that type of load coming down. It kind of depends on your loading. It definitely depends on your loading, rather. And that is very ductile. It will move, it'll sway, it'll do different things. It will actually, it'll sway over here. It can move. It's able to move quite a bit. On the other hand, if you have a shear wall in here, so this is a concrete shear wall, as it said, you're not going to be able to get that type of movement. You're going to try to move, and that shear wall will resist that movement, and therefore it's not very ductile. And then another example is when you have it braced. Let's say you have cross bracing down here. And this is this will not move as much as this moment frame will. So this tries to move. Let's say you try to move this way, and this tension member, this brace, will go into tension, and it will say, "Oh, no, no, no! You have to elongate me to move," and that will not happen very much. And you can go through. This is more of a detailed analysis if you wanted to go into a RESA program or similar type of frame program or analysis program. You could do these type of systems and see how it differentiates between different systems. But as you can see, if it tries to move this way as opposed to that way, this one will go into tension. And the reason they don't go into compression, you just assume that this won't. It will go in compression, but it's the tensile. Let me restate that. These members are typically so lean. They're very, very small compared to their length, and therefore they will buckle in compression before they will fail axially. So, in other words, that'll start buckling if it's going. Let's say it's going back this way. This one will be in what? If you think about it, this will want to go this way. That's going to be in compression, and this one will be in tension. So this one, tension, it'll say, "Oh no, you're not going anywhere." Compression, it'll say, "Okay, well I'll bend a little bit," and so you just assume that this member right here is seeing that entire load. All right, well, I hope that makes sense. I will do some later videos on to go ahead and explain it all, but I think that you got the point if you go ahead and read through this study guide, and it gives you a good base on why this is what it is, and to really go into anything more difficult and more intensive, I guess, would take a lot of time, and it would require some programs and whatnot. All right, I hope that helped, though. If not, just go ahead and post some questions, and hopefully I'll try to get to them as soon as possible. All right, I will see you in the next example.